So after I've showed you how to compute for the two-sample proportion test, let me now show you how to compute for the different chi-square tests using Statext. So first we would go over how to compute for the chi-square goodness of fit test. First problem is define P1, P2, P3, and P4 to be the proportion of deaths from SIDS that happened in the winter, spring, summer, and fall. So they are defined so that the seasons have about equal days. And then counts for the 4 seasons were 78, 71, 87, and 86. Are these different enough to conclude a difference exists in the population? So the expected count is 322, which will be divided into 4 seasons. So it will be 80.5 for each season. So the data would appear in Statext in this manner. So the observed frequencies and the expected frequencies from the problem. Then the procedure is easy. Just click on, again, categorical, and then choose the test that you need to use. And we just need to declare the observed frequency so that the application know which is the observed frequency. And then choose the level of significance and before clicking OK. So let me show you how to do that. So let's just copy here. I already typed it beforehand. And then click again on categorical, chi-square goodness of fit. Check if the observed frequency is row 1, yes. And then the level of significance, which is 5%, then click OK. So then the results would appear here. So for us to know for us to double check if we have presented the data correctly, the results also include a data table. So we just compare it. Row 1 is 78, 71, 87, and 86. It is similar to the observed frequencies as well as the expected frequencies for row 2. So going back to my PowerPoint, let's proceed to the results window. So here is an enlarged visual of the results window. So the conclusion is also included below. It says that the null hypothesis cannot be rejected. Why? Because the critical value of chi-square or the test statistics computed 2.10 is greater than the critical value of chi-square based on the level of significance and the degrees of freedom. So Statext does not show you how the degrees of freedom is computed, so that's another disadvantage of the application. So since the test statistic 2.10 is greater than 0.55, we need to accept the null hypothesis. So another problem for the chi-square goodness of fit test is table below shows the observed and expected frequencies and tossing a die 120 times. Test the hypothesis that the die is fair using a significance level of 0.05. So here's the table of the problem. So it's already arranged for us, so we only need to copy it on Statext. Excuse me. Same procedure. So let's apply it on Statext. We need to delete this first, then choose the test that we want to use. Copy and paste. There we go. And then click again chi-square. Observe frequency, always check row 1. And then the level of significance, because you can choose from 10, 5, and 1. So click OK. And then the results just appear on the table below, or the window below rather. So here, here it is again. Then the results. So based on the results, the test statistic is 5, the computed test statistic is 5, and then the critical value of chi-square is 0.41. So since the chi-square test statistic is greater than the critical value, the null hypothesis cannot be rejected. So it means, based from the statement of the results, the data meets the expected distribution. Moving on, let us go to chi-square independence test. So in the independence test, we are looking for a relationship between the two variables. So the first problem is eye color and shade of hair related in the individuals? Can we conclude from the data shown below that there is a significant connection between eye color and hair shade? So here's the table. So this is a contingency table, and we need to know if there is a relationship between the rows and the columns. So the data. X1 would be 23 and 4, and X2 would be 7 and 16. Why? Let's check. Oops. As you can see here, these are the real values and the others are only the totals. So we based it per column. So 23 and 4 is the first column for light hair, and 7 and 16 is the second column for dark hair. So using Statext, let's copy the data. And then click on chi-square independence test, and then state the level of significance. So the level of significance is 5%. Exchange rows and columns. Let's not. So click OK, and then let's see if it is the same as a table. So let's see. 23, 4, 7, 16. 23, 4, 7, 16. So apparently that's not how the table was constructed. So let's click exchange rows and columns. So let's see if it's arranged now. So 23, 7, 4, 16. Let's check. Yes, so that's how it is arranged. So here you can see, let's proceed because I already snapshot the results. You can see here this is the wrong screenshot. So let's use the one from Statext. We can enlarge this. It says 14, not 16. So here the chi-square Statext shows how the expected frequencies are computed. So here it is, expected 1 and expected 2. And then again, statement of the null and alternative hypothesis. And then the computation of the chi-square test statistics is 15.51. And then since there is a correction, the test statistic is 13.32. So here the degrees of freedom is stated, and then the critical value of chi-square is also stated. So we can say that since the test statistic is greater than the critical value of chi-square, we cannot reject the null hypothesis. So we should accept the null hypothesis, and the null hypothesis is the rows and columns are independent. So we can say that hair color and eye color are independent. So for another example, this is a long problem. People who get angry easily tend to be more likely to have heart disease. That is the conclusion of a study that followed a random sample of 12,986 people from 3 locations over about 4 years. All subjects were free of heart disease at the beginning of the study. The subjects took the Spielberger trait anger scale, which measures how prone a person is to sudden anger. The 8,474 people in the same who had normal blood pressure were classified according to whether they had coronary heart disease or not, and whether they had low anger, moderate anger, or high anger according to the anger scale. So the classification summary is given. So here the rows is for the existence of the heart disease, and the columns are for the level of anger the subjects have. So that's why we need to know if there's a relationship between the level of anger and the existence of heart disease. So here's the data. We just copy it based on how it was it appeared on the table, and then all we need to do is choose the test that we want to use and declare the level of significance. So let's do that. Okay, chi-square independence test. Oops, we need to delete the data and copy the data that I have presented here. So let's check. 53, 110, 27, and then 3,057 for 1,621 and 606. Okay, and then categorical chi-square independence level of significance is 10%. So always check 10%. So let's try with not exchanging rows and columns. So let's see if the rows and columns are the same. So it's the same. So we're right on not switching the rows and columns. And so here is the results. Let's check the results here. So based on the results, the critical value for chi-square is 0.003. It has no corrections because only the Yates correction is only applicable on 2 times 2 contingency table. So this is a 2 times 3 contingency table. So there's no correction here. And then the test statistic computed is 16.08. So it's greater than the critical value of chi-square. So we need to reject the null hypothesis. Oops. I think I made the wrong level of significance here. So looking at the Statext, let's check it here. Why is this level 0.05? Let's check. Independence, click 10, then okay. Oh, there we go. So at 0.1 level of significance, we need to reject the null hypothesis. So there is a relationship between the rows and columns. So the last type of chi-square test that I would show you using Statext is the chi-square homogeneity test. So this test In this test, we test the claim that the different populations have the same proportion of individuals with some characteristics. So our first example, how do women and men compare in the pursuit of academic degrees? The table below presents counts in thousands from the statistical abstract of degrees earned in 1996, categorized by the level of degree and the sex of the recipient. So the first column is the gender, while the succeeding columns is the academic degrees. So the data, I presented the data copying it based from the rows, and then in the procedure I just used the chi-square homogeneity test and the level of significance, which is 1%. So let's try to do that using the Statext. You can also present the data using the columns, copying it based from the columns. So categorical homogeneity, and then the data set, which is here, and then clicking the test, and then the level of significance we're using will be 1. So here is the results. So based from the results, the computed test statistic is 9.51, and the critical value is 0.0232, or rather 11.34 with an alpha of 0.01. So the null hypothesis cannot be rejected because it is greater than 0.0232. So let's try if we use the column, the academic degree column. So let's put x3, and then let's arrange it by 2's, I think. So 64,552, that's the first column, and then the second column would be, let's put x4, it's like 4 columns. So looking at the problem, let's check the here rather, this is better. So 642,522, and then 522. So 522, oops, 522, and then the second column would be 227,179, 227,179. The third column is 3245. 3245, and then the last is 1827. So let's check if they would have the same results. Level of significance is 1. So let's check the number of rows and columns. So that's not correct actually, but it gives the same results. So as long as you arrange your data correctly based on the rows and columns, and then you'll get the right answer. So the null hypothesis cannot be rejected. So it is accepted because the test statistic is greater than the critical value of chi-square. So moving on our next example. So next example here. This is the second example and the last example I will show you. So a dietitian wants to know if the time of day influences the tendency to consume coffee. The following data represents the beverage purchases for a random sample of cafeteria customers. The null hypothesis is that the proportions of coffee purchases throughout the day are identical. Using alpha of 0.05, what conclusion should the dietitian reach? So here is the table. And then using the data from the table, same procedure. It's always just choosing the type of test you want to use, declaring the significance level, making sure the rows and the columns are correct before you click OK. So let's do this last example. Oops, I think, yes, I closed the window. Okay, and then where's my trusty notepad? And of course, if you're going to copy paste things, you need to check if your datas are arranged correctly. So here 3, 5, 8, 11, and then again 52, 48, 51, 47, 52, 48, 51, 47. So based on this is the calculated test statistics 5.36, and then the critical chi-square value of 0.1471. The null hypothesis cannot be rejected at a significance of 0.05 since the test statistic is greater than 0.1471. Let's see if I did this correctly. There we go. I think that so yes, it is greater than the critical value, so we just need to accept the null hypothesis. So the null hypothesis is the distributions of the two populations are the same, or based on the problem, the proportions of coffee purchases throughout the day are identical. So there you have it. Here are my references. Thank you for listening, and I hope you did get valuable information instead of confusion in my report. So thank you very much, and God bless. So that ends my report on how to compute chi-square equations using the Statext application. I hope you have learned things on how to go about the Statext application, and if there are any confusion or other confirmations regarding the topic, you can look at the website of Statext. It's very comprehensive, and you can also see other examples there. So until next time, I'll see you again.